Till now we have been looking at logarithms with base of 10. Now we need not necessarily use 10, but the advantage of 10 is, say, 10 square equal to, right? So here what happens is log 10 of 100 equal to 2. So the number of zeros gives us an idea of the log. But other than that, and we are more comfortable with the decimal system. So other than that, there's hardly any other reason why we should use base of 10. Okay, for normal calculations, for normal applications, this is perfectly fine. That is base of 10. Let's say instead of using base of 10, we are going to use base of 5. Okay, so let's say we want to find log 5 of 450 equal to what, right? So just like we did for log to the base 10, let's do it for this. So 5 cube is equal to what? 125. 5 to the power of 4 is equal to what? 625. So which means 450 falls somewhere in between, right? 5 to the power of 3 point something, right? So we don't know what, but we know it is going to be 3 point something, and that's something we have to find. Okay, so let's proceed. 5 to the power of, let's say, x is equal to 450. Since we only know decimal system, that is base 10 logarithms, let's use that. So this becomes log of 5 to the power of x equal to log of 450. Log of x log of 5 is equal to log of 450. X is equal to log of 450 divided by log of 5. Yes. Now here remember, if nothing is mentioned, it means it is to the base 10. So now using the log tables or using the calculator, we can figure out x log of 450 to the base 10. Now that is equal to 2.653212 since I am using the calculator. Log of 5 to the base 10 is 0.69897000043. Now this is equal to 3.795888948. So now we know 5 to the power of 3.795888948 is equal to 450. Or in other words, log to the base 5 of 450 is equal to 3.79588894. So converting from one base to another is not very difficult. So in general, remember, based on this particular example, we know log 5 of 450 is equal to log 10 of 450 divided by log 10 of 5. So if you notice, this comes here. So in general, and we have seen this as part of the rules, so in general, log p of x is equal to log q of x divided by log q of p. So since we can use the base as anything, it would make sense to use some base which helps us in simplifying our calculations in some manner, right? So in higher mathematics, especially in calculus, a particular number is very useful. 2.718280 and it keeps on going. Now this number is called the Euler's number, and it is given a name just like pi, and that is E. Now very briefly, why we find this number interesting is that if you draw a graph, you will find that the slope of e to the power of x is equal to e to the power of x, right, at every point. Similarly, in integral calculus, integration up to x is equal to e to the power of x. Very quickly figure out from where this e comes, because it's a very fascinating number, and this comes surprisingly from compound interest. This was discovered while working with compound interest. So let us say rate of interest is equal to, let's say it is 5%. So year 0, that is at the beginning, the principal amount initially is 1000 rupees. So at the end of the first year, right, at the end of the first year, P1 would be equal to what? This 1000 as it is, plus 5% of 1000. Yes, 5 by 100 into 1000. Don't simplify it, don't do calculations. Now here if you notice, 1000 is common to both the terms. So 1000, 1 plus 5 by 100. Yes. Now at the end of year 2, what happens? We take whatever was there, so that is 1000 times 1 plus 5 by 100, and then we calculate the percent of that amount. So 5% of 1000 times 1 plus 5 by 100, right? So again, now don't simplify, common. So what is common to both? 1000 times 1 plus 5 by 100 is common. So 1 plus 5 by 100, which means we can say that it is 5 by 100 square. So what do you think would be at the end of year 3? Let's do it the long way first. 1 plus 5 by 100 square. What was there by the end of second year? Plus 5% of that. 5% of what? 1000 times 1 plus 5 by 100 square. So again, what is common? Common is 1000 times 1 plus 5 by 100 square is common. So if we take it out, what is left? 1 plus 5 by 100, which we can write it as 1 plus 5 by 100 cube. So year 2 square, year 3 cube. Okay, this is perfectly fine. Now here we are calculating the compound interest at the end of every year. So the periodicity of compounding is 1. So if compounding is done half yearly, then in that case the total amount we get would be what? The initial principal amount times 1 plus rate of interest divided by 2 the whole square times y. This is y is the number of years. Rate of interest 2 is what? Because we are going to calculate it twice a year. Now same thing, if compounding is done 4 times yearly, then in that case the amount we get is 1 plus r by 4 to the power of 4 number of years. Now this can be written as p times 1 plus r by 2y, p times 1 plus r by 4y. Now immediately you notice that this is to the power of 2y and this is to the power of 4y, which means that we get more interest, or finally we get a bigger amount the more frequently we do compounding. Okay, let's increase the periodicity, and for simplifying the calculations, let's take rate of interest equal to 100%. Yes, that means 100 by 100, 100% is 1. So which means 1 plus r by 10, let's say 10 years, will give us this expression for the inner part of it. 1 plus r by 10 to the power of 10. If here r is 1, okay, so this would give us, if we simplify, 5, 9, 3, 7, 4, 2, it keeps on going. 1 plus 1 by 100 to the power of 100 is equal to 2.704813. It keeps on going. Let's increase it further. So 1000 times a year. Remember, 1000 times a year we are going to do compounding. So 2.716923 ... Let's say we are going to do 10,000 times. 1 plus 1 by 10,000. This would give us 2.718145. Let's say we are going to do it 100,000 times. So this gives us 2.718268. Let's keep going one more time. This will give us 2.718280 and ... So do you notice it all is driving towards this number 2.718280 and on and on. Now this number is called, this is like pi, an irrational number, and as I mentioned before, it's called Euler's number. Now remember, we took rate of interest as 100%. Let's say r is equal to 5%, which is nothing but 0.05. Very quickly I'll do these calculations. 0.05 100 times will give me 1.05125796. 1 plus 0.5 divided by, let's say, 1000. This gives me 1.0512697.8. 1 plus, let's say, 5. 1.05127.108. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 gives us 1.5127.109. And this is where a jump is required. If you calculate e to the power of 0.05, you will get this number 1.51271096. So if you notice, these two numbers are approximately, to a very high degree, equal, right? So we can say that 1 plus 0.05 divided by, in general, what will happen? 1 plus, remember, this is rate of interest. This is rate of interest. So r by, and this is what? The periodicity, right? The number of times. So let's say that is k. So this is periodicity, this is periodicity. So k is equal to e to the power of r. So the final amount that we get after n number of years of compounding with a periodicity of k times a year is equal to the initial principal times 1 plus r by k to the power of k to the power of y. Now, since we know the internal, this expression is nothing but e to the power of r to the power of y. So, which means we can write it as p e r y. And e appears all over the place in nature. So for many areas of applications, logarithms to the base e is used, and this is so commonly used, this base, that it has its own notation. Remember, if the base is 10, we say log of x without writing anything here, right? We don't write anything here. If nothing is written, it means it is to the base 10. If it is base is, let's say, anything else, let's say y, then we write log y to the x. But if it is base is e, then instead of writing log, we write ln. So the moment you see ln, remember that the base is e. And whenever you see ln e, you can directly replace it with 1. Why? Because remember, even though it is not mentioned, the base is e. So log e of e will be equal to 1. Now finally, logarithms to the base 10 are called common logarithms, common logs, and logarithms to the base e are called natural logarithms. Okay, I think that's enough for today. Bye for now.